Hi, this is Mr. Wu, and welcome to this lesson on integer models for addition. Now let's start off and talk about the number line model. This is a very common model you see in your books, and it's a good one. It's sometimes you can also call it a directional model, and it works like this. You start at 0 on your number line, which is like your home, and you move to your first number on the number line, wherever that might be, a positive or a negative number. Now, adding a positive number always moves you right. Okay, positive goes to the right. Adding a negative number always moves you to the left. So you just add whatever that might be, you go right or left, and the number you end up will be your solution to that problem. Now I want to talk about another model which I really like to use, and it's called integer money. We can call this sort of a value model. It's a really good way of understanding kind of how these rules you learn for adding integers works. And if you don't have a number line, it's really easy just to think of it in your head, and it really helps you understand how to solve many of these problems. Now here are some of the ways this works, how it works. So type 1, you have two types of money. Money you have, which we can call cash, that's money you have, and we're represented by a green bill here. Now each card represents a positive integer, so this you can think of as $1, positive $1, money you have. The second type of money you can have, or actually don't have, is money that you owe. You can call this an IOU or a bill. Okay, something you don't have or something that you owe. And we're going to use red for that. Sometimes we say we're in the red. Now each card here represents a negative integer, so think of it as negative or minus $1. So in your account, what happens when you combine cash with cash? Well, that's pretty obvious. You get more cash, positive. Okay, there we go, two bills. It's like saying $1 plus $1 equals $2. Positive 1 plus positive 1 equals positive 2. That makes sense. That's just the normal addition you probably first learned. Now what happens when you combine IOUs, or bills? You get more IOUs, or debt. Okay, you end up being more negative. So we can say $1 I owe plus another dollar I owe means I end up owing $2. So minus or negative 1 plus negative 1 equals negative 2. And that should also make sense. You add things that are alike, you get more of whatever that is. Now what happens when you combine one cash card with one IOU? Well, they're going to cancel each other out. Think of it as paying off your IOU or bill. It's canceled, it's gone. So one IOU with $1, you end up with nothing or 0. So it's like saying positive 1 plus negative 1 equals 0. They're opposites, they're going to cancel out. You paid your bill. Now what happens when you combine different amounts of cash and IOUs? Well, it depends. They still cancel each other out. Positive and negatives cancel each other out. But will it be enough to pay off your IOUs or bills? That depends. What will you have left over? So you have to kind of figure that out. And how will you determine the type and amount? And the key to remember here is just use kind of your logical sense here. Like think about money and what would that look like? Example, 3 IOUs and 2 cash bills. So $2 combined with 3 IOUs still results in 1 IOU left over. These cancel out, but I still owe $1 left. I've only paid 2 of it. So what we call the integer equation for this would be 2, or positive 2, plus negative 3 ends up equaling negative 1. I still have negative 1 left over. I still owe $1. So try modeling these. Think about what we did here. Some ones. $5 combined with $4, $6 combined with 3 IOUs, which is a negative amount, 6 IOUs combined with $3, 5 IOUs combined with 4 IOUs. Now, I'd like you to write an integer equation to represent each. So using mathematical language here, using plus and minus, a positive and negative, and an equal, an equation. So write an integer equation to represent each. You can go ahead and pause this, and the next slide we'll talk about what these can look like. Okay, what did you come up with? $5 combined with $4. That's pretty easy. Positive 5 plus positive 4 equals positive 9. 5 plus 4 equals 9. $6 combined with 3 IOUs. Okay, now it could look like this. Positive 6 plus negative 3 equals positive 3. You had to pay 3 of what you owe, so you're going to have 3 left over. Right? 6 IOUs combined with $3. Okay, this one's different. Negative 6 plus positive 3 ends up equaling negative 3. Think of this, or you owed $6, you're able to pay off 3 of it, which is great, but you still owe 3 left over, so you end up still being negative 3. 5 IOUs combined with 4 IOUs. Okay, now these are like. Remember, we add things that are like, we get more of what that thing is. Negative 5 plus negative 4 equals negative 9. You owe $5, you owe 4 more, now you owe 9, right? It's a common mistake, and then a lot of times people confuse if the rule of multiplication is that, well, if I add a negative, I get a positive. And you think, wait a second, that doesn't make sense. If I owe money and I owe money, I'm going to owe even more money. Okay, so negative plus negative is always going to be negative. Just like a positive plus a positive is going to be positive. Okay, so just think, what makes the most sense? And that a lot of times will help you avoid common mistakes. Money makes sense because we use it every day. For more about and great activities involving these types of integer models, be sure to check out Positive versus Negative Investigations with Integers by the Ames Education Foundation.